Okay, here's a picture of this function right here. This graph right here. And we want to find the derivative of that function. Turns out this is it right here. But let's go to the next board and see that in action. If I enable both of these graphs, g prime of x and f of x, the graphs are identical, which kind of proves that g prime is equal to that function right there. And by the way, if I wanted to find equations of tangent lines to the graph of the original g function, I could use this as the slope. The derivative, I could also put g prime here times x minus x sub 1 plus g of x sub 1. There's the tangent line at the point where x sub 1 equals 1.9. So how do you arrive at that answer? Here's g of x again. And one way to think about it is using these sentences right here. Imagine that big F of u is an antiderivative of this integrand right here. And then if you were going to evaluate this integral using the Fundamental Theorem of Calculus Part 1, you'd put 7x into that antiderivative minus put 6x into that antiderivative. So there is one way to evaluate this integral if we went ahead and found this antiderivative. But now if we take the derivative of this, we're taking the derivative of big F of 7x. That means when we take the derivative of that term right there, we have to multiply it by 7. We're using the chain rule. And same for this. The derivative of f of 6 of x is 6 times f prime of 6x. But f prime is just u plus 2 over u minus 4. So we can replace this with 7x here, and minus 6x there, 6x there. And by the way, here's another way to think about it. If h of x is the definite integral from 1 to x of u plus 2 over u minus 4, and you want f prime, all you have to do is take this variable and substitute it in here. Because if you go through these steps, the term to the right minus the antiderivative of evaluated at 1 is just a 0. And similarly, if I put a 1 to 7x, I put 7x in for u, 7x in for u, but then I have to multiply by the derivative of this expression right here, which is a 7. So that's the easy way to think about it. Another way, let's just say we had 1 to x squared of u plus 2 over u minus 4 du. Well, we start by just putting x squared in for u. But then we have to multiply by the derivative of that expression right there, 2x. Okay, there you go. I'll also post a link to that Desmos graph. And if I share my screen real quick, you can see if I change this x sub 1, there's the tangent line to that curve, which is g of x, and I'm using f of x sub 1 as the slope. Okay, there you go. Hope that helped. If you have any questions, post a comment.